All right, part two. Arctangent. What does arctangent look like? Well, if you recall, even if you don't, this is what tangent looks like, where the period is pi, I think. There's an asymptote there and an asymptote there. So this would be pi over 2. This would be negative pi over 2. Yeah? And arctangent is the inverse, so that would be reflected about that line. So arctangent would look something like that. Where it goes, and those are the asymptotes. This is negative pi over 2. And this is positive pi over 2. Just to refresh your memory, that's what that is. Alright, let that be that. What is the limit as f of x as x approaches 1? All we are doing is, evaluating the two-sided limit. Remember, you got to do it from both sides. So limit as x approaches 1. From the left, we will use this. What is the limit of arctangent as x approaches 1 from the left? Well, we can use direct substitution. Arctangent of 1. What does that equal? Well, that's the same thing as saying tangent of what? Equals 1. And remember, that happens on the unit circle at pi over 4. Oh, look at that. Pi over 4 is one of the answers. Maybe it's pi over 4. So, what actually, in the unit circle, that would be pi over 4. All students take calculus, right? And then tangent is positive here, so this would be a positive 1 there. So what is that? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So pi over 4 or 5 pi over 4. So that's how we solve that. But now we got to take the limit from the other side. What is the limit from the other side? So the limit as x approaches 1 from the right side, we shall use this function because when x is a little bit bigger than 1, we could use that. Okay. Pi times 2, is it 2x? Menos 1 sobre x más 3. Okay. So, let's try to plug it in. We plug it in 1. So pi times 2 minus 1 is just pi over what? 1 pi over 4. There we go. There we have it. Okay, so the limit is just pi over 4. I guess it's not calling at me, so I can't fill it in. I just had a sneeze, but you couldn't hear it because I paused it. This is pi over 4. Questions? Of course not. Well, yeah, you might. If you do have a question, ask me. If I'm there. If I'm not, I'm probably dead. So, oh well. That's not true. Okay. The function f is defined by the formula. What values of a and b make the function continuous? Oh my goodness. So for this one, we have to take the limits as x is approaching 0 and as x is approaching 2. Yeah? And then to make it continuous, all of those limits have to agree. So I'll take the left and right limit as x approaches 0 for these two. I'll take the left and right limit as it approaches 2 for those two functions. And then I'll set the equations equal and solve for a and b. That looks confusing, right? But I'm just trying to make sure that the limits are equal. That's the big idea. So, limit as x approaches, let's say 0 from the left. That means I'm going to use 2x minus 3a. If x is approaching 0, then what do we get? We get the limit is negative 3a, whatever that is. Okay. And then what about the limit as x approaches 0 from the right side? Well, if x is a little bit bigger than 0, I can't use that equation, right? Because the function says only use this part, only use this function when x is smaller than 0. So I have to use this. So that's what I'm taking the limit of. Ax squared plus 2b. And then x being 0, that goes away. I just get 2b. So the limits have to agree. So I have to say that these two are equal. So negative 3a must equal 2b. For this to be continuous, they have to be equal. And then now I'll take the left and right limit for x approaching 2. I'll do that in red. Isn't this fantastic? Takes a long time. Limit as x approaches 2 from the left. Well, that means I'm using this function because from the left, that means we're plugging in things that are a little bit smaller than 2. And so we're going to use this squared plus 2b. If it goes to 2, then we just get what? 4a plus 2. Is that right? Yeah, because that's squared. 2 squared is 4. 4 times a. Okay, yeah. And then the limit as x approaches 2 from the right, we use this function because we're plugging in things that are from the right of 2, which is slightly bigger. And that's what this says. So, x minus 4, that equals, x minus 2. No, there we go. Negative 2. So, 4a plus 2, this, must equal negative 2. Because I want the left and right limits to agree. Whew, it's taking a long time. What? Subtract 2, a equals negative 1, right? Because you get what, negative 4? Oh, this is taking up the whole video. And then I can plug in a here. That's pretty sweet. What do you get? You get positive 3 equals 2b. I think I did this wrong. I see my mistake. It's supposed to be 2b here. So then this would be 2b. Okay. Okay, so let's erase stuff. Sorry about that. So that's wrong. Okay. I just copied it down wrong, alright? Settle down. Give me a break. God. Get my face. So that would be negative 2, so it's negative 4. No, not negative 4. Come on. I'm tired. 4a plus 2b. I feel like I'm going to sneeze. Has to equal negative 2. Yep, I sneezed. Okay. Alright, then what? Then what? Okay. It's just a system of equations. What? Yeah, these two systems of equations equals 2b. Well, instead of, I'm just going to use substitution. 2b and 2b. So, alright, 4a plus negative 3a, because that's what this is, equals negative 2. I just substituted this, this into here, because that's what 2b is. And then I just get a equals negative 2, right? And then I'll plug that back in to the top one. And what will I get? I'll get, what, negative 3 times negative 2 equals 2b. What is that? That's 6 equals 2.